All right. Hello, my name is Ken. I'm here with Ashley, and we are here to present our final project and to show you where our Sudoku game ended up. So without further ado, we'll get started. So you can see we've now added a GUI to our game. So you can actually click on things. You don't have to play with the command line, which was really difficult. So we'll start by clicking a new game. This new game will generate a full Sudoku board, and sometimes it takes a long time because of all the calculations it has to do. So we'll give it a second here. Alright, so you can see the board here. One thing we did do is we swapped it out so that it doesn't just use the numbers 1 through 9. We now can also use the alphabetic values in the name of the school, BYU-IDAHO, because it's kind of cool, and we really like our school, and so we thought that would be a kind of an exciting and fun little Easter egg that we could do. However, you can switch it back if playing in BYU Idaho mode hurts your brain, because it hurts mine. So you can alternate between the two by clicking on either of these buttons. And I kind of wanted to go in and show a little bit about how this works. The main heart and soul of this is this new interface we created called Sudoku Value. And this interface defines three different classes, or three different methods. Get value at ordinal, is valid value, and get ordinal for value. So to show you how that works, we'll look at the alpha values. And what these Sudoku value classes are supposed to be is they translate between the integers 0 through 9 into what it should display in the square. And then it also displays or converts back from what's displaying in the square back into an integer 0 through 9. So here you can see we have this enum, which consists of all of our values, BYU-IDAHO. And so get value at ordinal, what it is you pass it an integer, and it will actually return the string that corresponds to that integer. Likewise, you can call get ordinal for value, where you pass it the string, for instance a D, and it will actually map it to the correct integer. The reason we did it this way is so that we wouldn't have to change the code in our board class. Our cells rely on an integer, having an integer value. So what we did is the cells still use an integer, and when we're displaying it to you, the user, we just translate it, which happens in our text cell class. The text cell class is just an abstraction of the JText field. We did it that way so we could pass it a cell and interact more cleanly with the cells on our Sudoku board. So here you can see when we're setting the text, we just get the value from the cell, and then we ask the value translator to translate that integer into whatever it should display on the screen. And likewise, when you type something in, we just ask the translator to translate it back into an integer for us so that we can set that value on the cell. And to change it, we go to our game frame here, and we have these buttons, the BYU button and the num button, which are both radio buttons, and they have this action listener that's a translator handler. And basically what the translator handler does is says, hey, go get the action command for the button and tell the board to change its value translator to whatever that action command is. So if you go here to this method, you can see if it passes in alpha, then it will change it to an alpha values translator. If it's a numerical one, then it will change it to a numeric value. And then it will retranslate the board. So that was the bulk of what we worked on for that, and Ashley's going to talk a little bit more about some more features in our game.
Okay, so one thing I think is cool about our game is that any input from the player is automatically checked for validity. The way we do that is by creating this new text cell class, which makes each little box in our Sudoku board essentially its own class. So within that text cell class, we have right here this inner class called limit document. Within that limit document class, we have the two methods of insert string and remove. This remove method recognizes any backspace, and then when it recognizes a backspace, it triggers this change, which goes back to our change listener here in the game frame. And that change listener recognizes that when this action of a backspace is performed, it calls this refresh function. So in our refresh function, it goes through each little box in our Sudoku board and checks to see whether it's a valid input or not. And if it is valid, it's going to leave the box background color as white. If it's invalid, it's going to change it to red. So the way we have this refresh function, it recognizes any backspace so that it refreshes it each time a new input is given. So I'm just going to demonstrate that here for you. So I have here a new game in our Sudoku. So I have it in the numeric version. And I know here if I put a 7, that's an invalid input. And it automatically turns red. But if I backspace, it goes right back to white and it is waiting for the next input. I think if I put 5 here, that is a valid input, so it stays white. So that's one little feature of our game, and I'm going to send it back to Ken now.
Awesome. So that's the bulk of our game here. We are just, yeah. We also have our help menu, which is fully functioning. In earlier lessons, we implemented the application controller pattern to talk about those, to implement these menus easier. Sorry. And so I'll show you a little bit how that works also. So in our help menu, in our code, we have this hash map. And the hash map's like a dictionary where you have a key and it maps to a value. So in this one, we map a command about to the string we want to show. And we map, scoring to what we want to show. And each button has as its action command the command that corresponds to the string we want. So we add that action listener. It's just the same action listener for all of them, this menu listener. And all it does is when you click on the button, it gets the action command, looks up the string it should show you, and then sets the text accordingly on our frame. And that's how we are able to change this with very little code change. So that is the bulk of our game. Given more time, we would clean up the UI and maybe make it faster as it's calculating Sudoku boards, but we're pretty happy where it ended up. So thank you guys so much for your time.